metadata, the continuation of Cindy's talk yesterday. So, Alex.
Thank you very much. Good morning, everybody, and happy Friday the 13th. Yeah, I was telling that it's the second time I'm giving presentation on Friday 13th, and the first time I was in UNESCO headquarters and put on very scary picture and tell everybody that's how PIs look at me when asking for data. So it's, Friday 13th. And this is last day for you. It's great. It's very busy 2 weeks. I was asking people, how did you manage to stay here for 2 weeks? They said, we were busy. They've given them so much things to do, so they were busy and didn't have time to go to Captain Kidd even. But anyway, so as Heather said, I'm from Oak Ridge National Laboratory, represent Carbon Dioxide Information Analysis Center. It's located in Oak Ridge, Tennessee. Tennessee, that's why I have such a heavy southern accent. So please bear with me and just, if you don't understand anything I say, just, let me know and I will repeat, or, if you have questions as well, just stop me and I will say, sometimes like people have bad hair day, I have, or good hair day, I have good language day or bad language day. So you probably know that too. So anyway, so I actually don't have anything to say anymore because Cindy yesterday covered everything, and so I had to change yesterday my presentation because Cindy covered so much importance of data management and everything. So I will not tell you how important it is because it's already from Cindy's presentation. So I will cover everything about CDAC. I will be a salesman today. I will sell my data center to you. And maybe if in the future you're already working with carbon data, you will we will collaborate. You will send data to us, and we will put it online, and everything we have in our database free of charge, and all publications and everything. So I will cover everything what we have at CDAC, starting with introduction about history of CDAC and science and technology in general, Oak Ridge National Laboratory, environmental sciences, ORNL, and CDAC background. That's all you think, all you see I will cover in today's presentation. Science and technology at ORNL. So we are part of Environment and Biology division. And as you can see, we have energy, homeland national security, neutron sources, materials, environment and biology is where we are in computing sciences. And we have budget approximately $75 million per year for whole environmental science. And inside of environmental science, you can see so many disciplines we have: plant sciences, carbon cycle, ecosystem research, surface sciences, ecological management, and others. And between them, CDAC is right here. This is old slide, and CDAC, general CDAC already changed appearance and website, but still we call it pyramid of CDAC. And one of the components of this pyramid, it's ocean CO2. So how does it start? The carbon dioxide, CDAC was established in 1982. Funded and managed by U.S. Department of Energy, Office of Biological and Environmental Research, Climate Change Research Division. Dr. Wanda Farrell, DOE, is a program manager for CDAC, housed within Environmental Science Division at Oak Ridge National Laboratory, I told you that, and a science-oriented data center resulting in diverse data holdings critical to climatic change. Provide the full spectrum of data management services with data analysis and information services provided to anyone worldwide. Impacts. Quantify the most critical anthropogenic piece releases from fossil fuels consumption and the carbon cycle budget. Amazed with most diverse selective collection of data, fundamentals, climate change research in the world. Assembled the world's richest collection of ocean carbon measurements, that's me. Satisfy over 500,000 requests annually to diverse audience and users worldwide. Most models associated with climate change over historical time use CDAC data. data distributed by CDAC are better than data arriving to CDAC. That's true. We call it value-added data and services. Example of scientific issues, questions addressed by CDAC or data furnished from CDAC. Quantifying CO2 releases from fossil fuel consumption over multiple temporal and spatial scales. Elucidating global and regional trends, ocean carbon transport, and can you read just because you just can read it because this is not my slides. I was given by director of CDX and just presented, in case people know. Yeah. So we have multiple sources of data, and we just identifying regional scale trends and observed cloudness, everything you can imagine, addressing the sensitivity of biological models, and on and on and on. This is important. Science citation index shows more than 1,500 scientific journals cited CDAC products between 2003 and 2009. What we have present data holdings at CDAC. We have 450 data sets totaling 500 gigabytes. I don't know if it's a lot, right? Terrestrial, oceanic, hydrospheric, atmospheric, crystospheric, pedologic, classic, unique, not available elsewhere, temporal scales ranging from 1 second to millennium, spatial scales ranging from point source to global scales, vertical profiles from 600 meters below surface to stratosphere, field campaigns, network-wide database, and other. And our products, we have, I will stop on numeric data packages, CDAC numeric data packages, databases, trans compendium, synthesis products, network-wide databases, and stuff like that. You can see this. Most popular holdings at CDAC, it's our trans compendiums, GLODAP database, second place, Ameriflex holdings, Manolo record, and fossil fuel series. This is our most requested products. So this I already stopped on that. I don't know why we repeat this also. So you read it. I just go through general CDAC stuff and stop on my oceanographic. Here this in red. Can you see it? Ocean carbon dioxide and other measurements. That's where we start. Okay, U.S. Ocean Carbon Project origins. In 1989, beginning of Joint Global Ocean Flux Study. In 90, beginning World Ocean Circulation Experiment. And DOE and NOAA funded 10 U.S. institutions to develop instrumentation and perform carbon-related measurements on those cruises. That's when everything started. So you've seen many of those people here. Princeton, Bob Key, Chris Sabine. Yeah, that's time Chris Sabine was postdoc at Princeton with Bob Key. And at the local here was Catherine Gaillet. If anybody know Catherine, you know Mary, because she was working at Woods Hole for a long time, and now she's back to France. At Scripps, Andrew Dixon, Charles Keeling, late Charles Keeling, and Ray Weiss. University of Miami, Frank Millera's group, and University of Hawaii, Chris Wynn, Tara Takahashi, Doug Wallace, Linda Bingler, and two NOAA groups, Rick Wineikoffs and Dick Philly, were developing and performing CO2 measurements during World Ocean Circulation Experiment. It's hard to believe that during those CO2 measurements were not actually included in the those measurements in the beginning. And thanks to JGOVS and Department of Energy and NOAA, these measurements were performed, not on all, unfortunately, but on most cruises. And so that's why we have now GLODAP product, because we started during WoS era to measure CO2, and I'll touch it later. So what's CDAC's role in the global ocean carbon projects? In '93, CDAC became a member of DOE NOAA Ocean Carbon Science Team with data management and data activity archiving responsibilities for WoS CO2 data. In '96, CDAC was invited to participate in the UNESCO IOC panel for underway PCO2 measurements. In '98, CDAC became a member of PICES. PICES is a North Pacific Ocean Science Organization, and that's when we started working group 13. It's a carbon group, actually. So in '98, we started carbon group at PICES. In the same year, CDAC became a member of CARINA project. We started CARINA. You probably have heard already about CARINA and GLOBOP many times during these courses. So that's when CARINA started. And I don't know if Bob Key, Scott, touched the CARINA history a little bit, right? No, not really, but it started in '98. We had a meeting in Germany, and Doug Wallace and Ludger Mintrop, they were, like we call them, parents of CARINA, but it was not funded by any means. And by 2001, it just slightly gone down, and because Ludger Mintrop had to move to different position, but now we finished it, and I will stop on CARINA later a little bit more. In '99, GLODOP project started. CDAC is a member of GLODOP science team funded by DOE and NOAA. In 2003, GLODOP database was published by CDAC. So that's when it started a boom of, we doubled our requests for data on this year. In 2003, CLIVER repeat section project started, and CDAC is a member of US CLIVER science team funded by NOAA. And same year, VOS, it's volunteer observational ships, and time series project started. CDAC is a member of these two projects also. In 2004, CDAC involvement in International SOLAS program, and I was a member of implementation group 3 and data management group in those organizations. In 2005, we started synthesis work on understanding and temporal evolution of the global carbon cycle using large-scale carbon observations project. CDAC is a member of those teams. And in 2005, we started to be involved in North American Carbon Project. And in 2005, European Union Carbon Ocean Project started, and CDAC is a member of Science Steering Committee. In 2006, CDAC member of Carbon and Climate section. It's a group became a section. It's more serious, and in PICES, North Pacific Organization. I will stop by there too later. But CDAC in 2007, CDAC member Ocean Sites Data Management Team, and same year CDAC became a member of Eurosites Oversight Committee. And in 2008, CDAC a member UNESCO ICP Science Steering Group, and CARINA database was published in CDAC this year. So see, I'm trying to be involved everywhere because we need data. And it helps a lot, like organization of Carbon Ocean, European Union project helped me a lot with CARINA and European data, because politics before Carbon Ocean wouldn't let me get carbon data from European Union, but now it's very easy with this. So what's CDAC Global Ocean database components? World Ocean Circulation Experiment database, GLODOP database, CLIVER repeat hydrography and carbon database, VOS underway PCO2 database, moorings and time series database, global coastal program data, CARINA database, global surface ocean alkalinity climatology database, Lamont database, or we call them Takahashi database, global surface PCO2. And this is our website. This is not CDAC, this is part of CDAC. This is ocean CO2 part. As you can see, when I started this website many years ago, actually it was, when Mosaic started, I already, was thinking to put everything online, and we didn't have graphics and anything. But now with all this technology, we have so much opportunity to do things we want to do. And design of website, I decided would be need to have just one click away from major projects we have, major data. So you don't have to look anywhere else, not even search. Even so we have data search engines, I will show you later. I decided that to put on front side all these projects we involved. So just click away and you're there. So let's go to live. I'm glad that I did all these slides in case internet would work slow, but if internet's amazing here, and I just want to show everything live. So I hope it works today as well as yesterday. Anyway, so we start with WOS. This is a map, clickable map of all WOS cruises in global cruises with CO2 measurements. So I put it together. It was before we had even developed search engines. So I decided that this map would show location and number of line, and people would just come here and click on line, on the line number and or name, and just get the data. And here it is. We describe data set, for example, P10. I just get it as example because Chris Sabine was my friend. Chris Sabine was PI for carbon measurements. And we have information, this data, little table information for all, everything you need to know about this cruise. So we even have little plots for ocean carbon distribution and plot of this line, and information about ship, place, period, chief scientist, carbon-related PI, and all these measurements in data set, and data access. And we published our numeric data package. It's available online, or we also used to produce hard copies of these numeric data packages, which I have a lot. And this is basically a report about this cruise and information about everything, about ship, about cruise summary, and short information about hydrographic measurements, full information about CO2 measurements, like total CO2 alkalinity, if underwave CO2 measurements were performed as well, radiocarbon, and what we did with data checks, processing. So this is basically a publication describing this particular cruise with access to data. So if you need data, you just click on here, and you can get all data files for this particular cruise. See, this is was done in what year? In 93, 99. So that time we had, if you can imagine, we had even Fortran files to read. I wrote Fortran files so people could download Fortran program and to read this, but we don't need it anymore. I stopped doing this because people use so many different systems to read the data, especially Ocean Data View. It's amazing, and you probably had already lesson with Rainer. And I use Ocean Data View all the time. Anyway, so this is how, and metadata. How many times yesterday we heard metadata from Cindy? It's very important, yes. This is proof that we take care of metadata very carefully right now. So I will talk about metadata later. Just wanted to show that we have at CDAC we developed Mercury. We call it Mercury. It's a metadata search engine, and we enter all information we know about cruise into the Mercury. And Mercury, it's XML I'm not familiar with this all, but it's XML files actually. And it produces report. When we enter information, it produces a report. And you can see this. I will stop here again later on the Mercury if I have time. But you can see that all metadata, absolutely everything you can get from PIs, we put here in metadata report. How do we do it? I will tell later, but you can see here the vessel name and the country and information about location, cruise ID right here, and we have start date and end date, all measurements in database, and of course, most important, we have information about methods and instrumentation used to measure total CO2. See, so much information we have, but it's very important. Alkalinity, so much information we have. I mean, that's PCO2 data was not measured on this cruise, so we have blank. Also, very important citation of the data set. So we always have citation offered. That how would you cite this data set if you use the data from this one. But I stop later on this. Before I go to Kozyr, take a note here that, see, we have repeat sections now going on. So we have historical, both now it's historical data, and I decided to put together two sections, the same section, P10, on this page, so people wouldn't go anywhere else to look for repeat section of this line, repeat line. So see, I have those. If we have repeat section, I put together it on the same page, Kozyr repeat section P10, and you can see it was done in '93, and new repeat sections was in 2005. So people can grab data from here and just do calculations and see changes and everything else. So this is about those. Now, Kozyr. As I told you before, that Kozyr started in 2003. 2003, repeat sections began this year, and by now we have so many cruises already done in the world with different countries. You can see how many countries involved in the repeat sections, and if you see dashed line, it means data was not submitted to CDAC, but it's pretty good that we have all data from these sections already in CDAC. So you see solid lines in all oceans. And again, you click on the cruise, and you will now you have reverse picture. First, you have Kozyr repeat section data, again with metadata information from Mercury, and historical data now it's P10. So all together on the same site. So you wouldn't have to go different places on the website to look for the data. Okay, and of course our very popular project it's a GLODAP. We put together this website just for GLODAP, so people would log into this website and get all information about this project. And I'm not going to repeat how did we do it and everything. You can read here introduction and results. Basically, result tells you about GLODAP lines. See so much data. I think I have here. We have 122 cruises, WOS and GGOVS cruises, and historical cruises in this GLODAP database. And you can see that red, it's WOS, US WOS cruises. We divided it's DOE cruises, and yellow it's NOAA cruises, and blue not non-US cruises. But all data here at CDAC in this database. And of course you see studies and carbon thermodynamics, anthropogenic CO2 calculations. Chris Sabine did a good job on that. Bob Key did the radiocarbons studies, and Bob Key also performed calculations of gridded carbon fields. So gridded data, GLODAP gridded data also available here at CDAC. And if you go to ocean, we divided database by oceans. So for people who don't want everything, they just can get in ocean, just one ocean data. And so we have these tables to help you to find out about details about cruise summary. So it's the same like cruise summary. You have all information on each cruise in Pacific Ocean and who PIs and measurements, how many stations those measurements were here, and we keep doing this for new data. Also detailed information about specific correction factors after we finish synthesis and perform the quality second level of quality control. We decided, and it was like a decision to make some corrections for some data in some cruises, of course with PI permission, and so we did it. And this table gives you information on corrections for each parameter for particular cruise. Most cruises in the database are without corrections. So basically what we have those database from a map. You can get original cruises with no corrections as they were sent to CDAC, of course with some quality control and flag change, but still we call it original data. And GloDAP has synthesized data. It already includes corrections, so it depends what you want to do. Use GloDAP. It's level data or original cruise, so you can go and get both. And this was very important measurements. Table. I'm sorry. You know why? Because that's what Cindy was talking about yesterday many times. If we don't know something about cruise, it was very difficult to find out. For example, sometimes we don't know if during cruise there were duplicate measurements performed, because duplicate measurements help you to assess quality of data. The most important information was when CRM, Andrew Dixon introduced CRMs, some institutions started to use CRMs right away, some not. And we couldn't find information about whether CRM correction was applied to data or not. We didn't know. And it took 2 years to get this information together and talk to PIs and find out if the PI submitted data with proper metadata information, we wouldn't have to spend so much time just to get this information. And so that's why Cindy many times yesterday repeat metadata information. Metadata is very, very important for future studies, future synthesis work. So I wanted to show you this table, because this table took a lot of time to produce. But finally we did, and still some information we didn't get. All data are here. You can see that data can be obtained from CDAC. It's as a gridded bottle data, gridded and bottle data, different files by oceans. We present this data, this LAS. I don't know if you've heard about the Live Access Server. It's a PML production. So far we have old version of LAS. They completely redesigned LAS, so I don't even try to show you this because it's brand new LAS and we didn't get it yet because they're so busy to put together other stuff. But it will be available through LAS. It's a very nice tool right now. And we present also data through Ocean Data View. So I put bottle data and gridded data into the ODV format, so you can get all data from there. Okay, and one more thing about GloDAP Atlas. I produced Atlas for each line, each section. So you click on Ocean and you see so many lines in Pacific Ocean. And if you need high resolution graphic, I have two formats in JPG and PostScript format. So it's a high resolution graphics of plot section. It's supposed to extend. I don't know if you yeah. So it's probably reduced format. But anyway, you can see this very high resolution of plot section of total carbon dioxide in this case on the upper 1,000 meters and whole column measurements. So if you download PostScript format, you can use this graphic, and all sections for each ocean have these graphics here. So we call it GloDAP Atlas, and it's also widely used. That's all for GloDAP. And just briefly, I stop on other projects we have. We have VOS project, also it's clickable map. This all VOS cruises. VOS, it's volunteer observational ships. Basically, it's cargo ships or research vessels with automated CO2 system on board. And even now, nobody has to be there. They're just, working very, very fine. And they have, for example, Japanese have frequent cross-Pacific Ocean cruise of these 3 ships, and they measure data very widely there, and we receive this data from Japan and data available at CDAC. So also this all information about measurements, instrumentations here, and we have also in Mercury information about these measurements. So it's a lot, and basically Taro Takahashi did all his database based on these volunteer observational ships observation and measurements. Okay, the same project we have with time series, this whole time series with CO2 measurements on this map, and some data, this is very difficult to get data from time series because they think, okay, 1 more year we get data and then we send it to CDAC. So it takes some time to get there. And you can see how many countries involved in this project. So I couldn't find the colors to get on the map. But anyway, so this all clickable also measurements and tau. It's again Chris Sabine responsible for this tau moorings and information about position, buoy position. It's a buoy actually, and data access here goes to CDAC, and you can get data from this time series and moorings. In other projects we have, it's recently we put together this global coastal data program because we involved in North American carbon project. It's an ACP we call it, and they need a lot of information about coastal area carbon measurements, and so we put together this website. Also, it's clickable. You can get data from these sites. It's not just include surface data. You have surface underway measurements and bottle data from the cruises along the shore, and time series and carbon moorings also involved in this. So far we have three sites. So you see this east coast of United States, west coast also have some data. It's not much populated yet, but we just started getting this data information online. And and one more we have. I work with European community very close on European data, coastal area data. So we have this all data available at CDAC right now from these sites. So I'm very excited about this one. Okay, now Karina. This just finished. Not particularly finished because Bob Key finds some mistakes and send me more and more and more new versions of data. But I'm glad we finished that project, and I just recently opened this website just for Karina, and you can see, you can look at the Karina measurements on the map from different prospects. Like this is North Atlantic map, so much measurements we involved. And if you want to look in the Arctic, it's also, you can look how many stations we have in the Arctic, and of course Southern Ocean measurements of Karina. So all information about Karina you can read here. This project history and everything. That's why I just don't want to repeat it. It's not much time left. And we just published numeric data package for Karina, and you can see this Karina group involved 49 people from different countries, mostly Europeans, to do the synthesis work for carbon measurements, not just carbon, all measurements in Atlantic Ocean. And all information you can get here from this website and read about everything abstracts, and this is how would you cite Karina if you use data in general. But we have Oh, by the way, Carina Group information, this all names are here. And Toste was he had a lot of responsibility in this work, so he's number one here. And Bob Key decided to be last, even so he did major work on this Carina. He said, if not first, I will be last. Sometimes he's funny. All cruises, also, like I said, we have original cruises data you can get from this table. So this is informational table with data access. This Carina table. We have 188 cruises in this table, and all cruises data available by cruise online. So if you click on data files, you can read metadata here, and also it's in Mercury with a special format, metadata format, and comma separated file is here for each cruise. And if you want to know more about like publications for this cruise, or we have a lot of footnotes, so you can see what already was published about this particular cruise. So it's available from this page. And of course, map for each cruise has a map of measurement location. Okay, so first thing, we have data for each cruise, and then again, like Glodop, we have Carina data product, and Carina data product is available here, and it consists of 3 different products. I mean, database. We divide it by regions. So we have Arctic Mediterranean seas, we have Atlantic Ocean, and we have Southern Ocean. And as you can see, we presented data separately here, and you see version number. As I told you, Bob Key is changing some stuff. So for example, AMS has already 3 versions. Version number 1.0, 1.1, and 1.2. And we keep them all because when we published version number 1.0, people started to do papers and publish papers, and we don't want to lose it because they made a reference to this version, so we're going to keep it forever. But we put together, and each version has separate reference. And now we started to have, how they call it, digital object identification, right, Cindy? DOI. So identifier, yes. So now we have DOIs for each publication. In this case, each version has separate DOIs. So you would refer, or if somebody wants to find this information, data, or publication, goes to DOI center and click on, search this DOI number and find data, or find data in publication and anything else you'll find. So as you can see, we have information for each version here, and you can get data from here. It's a zip file. So this is Carina product, and we urge people to use Carina product because it's been, it's gone through second level quality control. It's very clean and very nice data set. So this is Carina, and of course we present here MATLAB routines, so people would know how did we do it and what means, and if they want to use it, they can get all routines from this website. And of course, secondary QC and final adjustment for Carina cruises table, and this is interactive table. It's not at CDAC right now, it's in Germany at IFM, but it's going to be moved to CDAC when we completely finish Carina. And here, it's interactive table. It's a very amazing tool. People Toste and others put together. So online you can check crossovers and everything. You can you can see graphics and everything on crossover analysis and everything. So it's very, very useful tool when you do the synthesis work. It's amazing. So it will be at CDAC soon. Okay, and so we have Carina publications. All these publications is a result of Carina project, and they're published at Earth System and Science Data Journal. And so we didn't finish Carina, but we already have so many publications in the journal with reference to Carina data. So that's all about Carina so far. I don't see any questions. I'm speaking clearly, I guess, right? I'm glad. Maybe I have good language day today. Okay.
Going back to the GLODAP Atlas,
Mm-hmm.
when you show the Atlas pictures, you don't have to pull it up
Okay.
necessarily, but is there some place where you describe the choices you made in ODB, like whether you used interpolation or anything like that to create such a plot?
I have these all methods, right? But you're right. I didn't put it on the web. Yeah, but I keep strictly these numbers. I know what you're talking about. This gridding stuff in ODB.
Right.
I keep it in my documents, so I would do it again and again because sometimes I forget.
Exactly.
But you're right. Maybe I should.
For someone
Yeah.
who's learning to work with the data to say, well, how can I make a plot that looks this good?
Uh-huh.
Well, how would I?
Yeah, you're right.
Would I take?
It's
So-
very good point. Very good point. I didn't think about it, but yeah, you're right. I mean, it's very important to have this information, and ODB is an amazing tool, but you need to know. But again, when I started to do it, I played with it first, and you play and you see how does it work. Of course, it's a resolution in the upper. It's different than the resolution in the lower graphic. And also, I was consulting with Chris Sabine and Bob Key about that. They told me the better way to do, stuff, greetings like that. So, but I have everything documented. I didn't put it online. I didn't want too much information. We already have so much information about GLODAP. So, but yeah, it's very, very good point. Okay, so just few weeks ago, I was in Korea on PICES meeting. PICES, as I told you, it's a North Pacific Ocean Science Organization. It includes 6 countries around the North Pacific represent, the members of the PICES. So on this side, United States, Canada. On the other side, Russia, China, Korea, and Japan. So 6 countries represent, involved in PICES. And we decided to do start data synthesis on Pacific Ocean data we have. By the way, I forgot to tell you the important thing that Carina database doesn't include any cruises, maybe just few, any cruises from GLODAP. It's new, so we did not include just a few reference cruises. We used reference cruises for crossover analysis, but we didn't put data into Carina. So GLODAP is different from Carina, and PICES database will be, we will call it probably CARP, Carbon in Pacific Ocean. CARP database will be different from GLODAP again, but at the end, in the future, when we produce PICES version number 2, it will include Carina and, GLODAP version number 2, I'm sorry already. GLODAP version number 2 will include Carina and CARP database in it. And we still will have separately GLODAP, PICES, and Carina database. So anyone can just choose what they want to use in their research. So this year we started PICES database, and Bob Key and I involved heavily in this, and I put together this table from cruises I could find from this side. Not many so far, but still we have data from all these cruises for PICES database. This is separate cruises, and our Japanese colleagues put together the same table from their side cruises, and they have a lot. I tell you, I don't have a map of PICEs so far we have, but it's probably about 210 cruises right now we already have, mostly of them Japanese cruises, and which is good. So we just started to do that, and Bob Key finished Carina, and now he can download all these cruises, all data to his system in Princeton and start to do synthesis work. I mean, just to do a first level QC for each cruise, start from the scratch. So this is PICE's database. It's a future. Will be in the future. Lamont, yes. No, we call it, PICES is North Pacific organization, but CARP will be Carbon in Pacific Ocean. We will not divide. You're right, because in the beginning we called Carina, it's Carina in North Atlantic Ocean. We thought that we will do synthesis work for North Atlantic Ocean, but it doesn't work. You have to include everything in ocean, so in order to get thorough assimilation of all data and everything. So Pacific database will be also full ocean. Okay, another database we have at CDAC, it's a global surface PCO2, or we call it LDEO or Takahashi database. So far online we have two versions. Version number 1 has 3.5 million measurements in it. This is map of all CO2 measurements. Can you imagine how much time Taro spent to get all this stuff together and he did the synthesis work on that too, reformat and reconcile and everything. So it's amazing work done. And then in 2008 we put together version number 2007. We decided to call it not 1 or 2, but by year. That would mean that we have data up to December 2007 in it. And this version has 4.1 million points. And just before I came here, Takahashi sent me version number 2008, which has, I don't know for sure, but more than 5 million measurements in it, including all measurements, new measurements in 2008. So data available online, and Takahashi's gridded database also available here. And we produced numeric data package describing, Taro Takahashi described in this all his work actually. What did he do and how did he do it and everything, data listings and all information. And I will stop on this database later when I present our WAVE system. And another project which is under construction right now, but it's SOCAT. It's a surface ocean carbon atlas. It's work done by, not done, but it's continuing. It's European community with within the Carbo Ocean project. But I'm involved in this too, and it's underway right now. This work, synthesis work. So it's like a counterpart of Taro Takahashi's database, but even more. They have already about 7 million measurements in it, and they do it differently. Taro Takahashi not particularly happy about that because he thinks that they do some things not right. But I don't know. When we put it together, we put it online, and users will decide what to use. So you can use Taro Takahashi database or SOCAT database. But here we will have more calculated measurements in SOCAT, and so it's going to be big database, also available soon from CDAC. I think we're going to put it together by the end of 2010, and it's going to be huge database. Okay, I think I stopped on all our projects we have, right? Now I want to stop on very important thing on data submission, data format. As I told you that, no, let me first stop on our systems, data search systems. So I told you about Mercury, and we have Mercury developed at ORNL It's in-house development. And basically, as you can see, this metadata search system based on XML format files. And you can put simple search for, just a keyword here, or you go to advanced search and search for the data. This is a separate instance just for ocean CO2, because we have at CDAC also Mercury, which general Mercury for CDAC, but CDAC has many disciplines and we have all different data formats. So I decided to have my own Mercury just for ocean data. And as you can see, I divided by measurements, like we have discrete measurements here or ocean underway measurements. So you can uncheck or check what you want. And also you can search by investigator name, dataset ID, experiment name, cruise ID, section number, or of course geographic area. You can use a map to do that, and it's already. For example, if you want to just, let's say you want to have to know how much data Chris Sabine sent to CDAC. You just, put 2 letters and you find Chris Sabine right here. And when you click and do search, you will find that Chris Sabine sent to CDAC 19 underway data sets and 11 discrete data sets. You can also filter by geographical region here, by oceans, or by cruise ID. There's so many cruise ID, or even by variable. So it's a very powerful tool. And again, if you see the list of results here, you click on View, P10, the same cruise, and you will get this report. It creates online on the fly that reports. So you see this report I showed you before. It's a metadata report, very, very important metadata report from Mercury. So this how, and it has link to original data. So in this case, it's underway measurements, right? So you click on here and you go to the section where you can get original data. Okay, so it's very good for metadata search, and you will know everything about that. Another system we just recently, this is different. This is data search system based on relational database. So far, it's included only GLODAP data. It's so you can search again by regions, by oceans. For example, you just want one ocean to get everything from one ocean, and you can see all cruises. You can choose particular cruise from here. Of course, you can put coordinates here, and you can search in query parameters. You can put depth. For example, you just want surface data. You can put from 0 to 0, or upper level data. You can put here, and salinity. So you can search by all these means, and output parameters you can choose from this list. You just check all parameters you need the output for the data. And for example, if you want to just search a little, part of this ocean, so you can do that. And this is very important again. Remember metadata word right here. So in this area you choose, you have information about all cruises in this area. And what's important about this wave system, that it talks to Mercury on the fly. When you choose area and maybe just one station included in this area from cruise, you click on this cruise and wave system talks to Mercury and gives you information about all these cruises in this report, Mercury report, metadata report, as I showed you many, many times. Just to make another stress today, as Cindy did yesterday, metadata. Yeah, so here all cruises in this area, and you choose, and you can download all these reports, and then you want to have, for example, you want to have some data from it. So you just check all, or let's say you want, I don't know. So you can look at the on-screen table first before you download data. So you open it. See, it's a little bit slow, but still working. So you look on-screen table first. If I don't know why, but in case we decided to do this option, so people could look at the data. Some people like to look at the data first. I don't know why. And again, cruise ID, if you have cruise, it's links to Mercury right here. Again, it's links to Mercury, same Mercury with metadata information. So we always have metadata information with it. Okay? Or if you want to download the file, you can choose from these three different types. We have comma separated value, top separated value, or netcdf file. Yes, Waves creates netcdf files for data you want to download. Or if you want to look at some plots, you can make a plot online if you're interested in relation between, let's say, pressure and total CO2, and you want to see in this area what's the distribution of total CO2 with the depth. So it creates online plot right away. See, so many outliers, but I'm sure this with flag 4, which are not good. But anyway, so you can look at the data before you download the data. I think it's a pretty good tool for online tool, from HTML tool. It's not software. It's based on relational database, so it's very good. Okay, and in other Waves we have for Taro Takahashi's database underway measurement. So again, here you can basically do the same. You choose area, or you can choose particular cruise. For example, if you want just have meteor cruises here, it selects for you meteor cruises in the Atlantic Ocean. And if you want on-screen table, also gives you you check these all parameters. Taro Takahashi has so many parameters in his database, so you can choose all of them, or just one of them, or two of them, and put together. And again, metadata. Right here we have information about each cruise for Meteor in this case, and information about each cruise. And also we have information in Mercury. We didn't make yet. We will make this also contact with Mercury in the future. So far, this is just little information about cruise here, so for information only. And again, you can choose download file in 3 different formats, or you can make a plot of, let's say, underway PCO2 at sea surface temperature, and we can make a plot and see what was measured in the Atlantic Ocean during this particular time. I hope it's fast. So you have plot of all these lines, underway measurements, and you see sea surface PCO2 at sea surface temperature measurements here. So it makes these plots on the fly. So this is as to our system, Mercury system. Waves system, and it was developed in CDAC. I had this idea about this system for many years, but I'm not very good programmer. And finally, we got a little bit more money for that, and I hired a programmer, and he basically developed. He worked for 2 years and developed these two systems. Waves for discrete and underway measurements, which is very good, I think, for people, and it's widely used because we have information who is logging into this system and who is doing what, and it's amazing. Like we have, I count once, probably about 25 countries, 1 month, 25 countries, people from 25 countries logged into this Wave system, and it was amazing. So it's widely used and widely known. And I'm not going to talk about LAS because again, it's under rebuild. They rebuilt it in PML. It's not our creation. It's PML. Steve Hanking, if you know this name from PML, he's in charge of this system. Okay, now we're going to talk about submission. By the way, here on general information, you can read information about each project we involved, what is it behind these projects here. And so how do we do this Mercury reports from these systems, from these forms? So we ask PIs before they submit data to us to fill out this form. We have two forms, underway PCO2 metadata form and discrete measurements for metadata form. And they're different, and they actually reflects their reflection of Mercury metadata report. It's absolutely the same fields. Who else know better about data, about cruise than PI? For me, it would be very difficult to find all this information if he wouldn't send it to me. But in this case, PIs just put his name, information about data set ID and everything you can see here, and cruise ID, expo code, geographical information here, and date started, date finished, vessel information we also have here, and of course method description. For this PCO2 measurements we have equilibrated type, equilibrated volume, and all this necessary information for future synthesis work or for others who would do science on using this data. And other sensor resolution, uncertainty, environmental control, manufacturer name. So all this information PI would need to fill out. We don't say that you must do it. We say we should do it. So it's softly, so PIs, if we say must, sometimes they say, and they wouldn't send data to us. So we are polite. We say, just please fill out this form. And it's very easy. And if you have data somewhere in a link in your place, put it here, or attach file here. It's very easy to browse your computer and attach file and submit it to CDAC. As soon as they hit submit data, I will receive notification on my email that I received new data, new metadata, and I use this form to create Mercury metadata report. Basically, it's already done. I mean, it's automatically, I can put it in Mercury in a matter of minutes if I have. Of course, after quality control of the data, because, as I told you, data coming to CDAC is not better than data coming out of CDAC, so I have to do some kind of value to add value to the data. So that's a form we use, and we try to convince all PIs to do that. And discrete measurements also, you saw reports from P10 cruise. It's the same information basically. You need to fill out information about every measurement. In this case, total alkalinity, PCO2, total CO2, and pH. Here information, and again, attach file and just hit submit, and we will have file. And we have also we offered underway PCO2 data file format. We didn't offer discrete measurement format because we use we use exchange format, which was developed at CCHGO, former WOS hydrographic office. So in our database we use the same format. So because we work very close with CCHGO on repeat sections, and all PIs who measure CO2 on repeat sections send data to CDAC, and I download the hydrographic file from CCHGO. You have a question? Oh, I download hydrographic file from CCHGO. I do quality control for CO2 measurements. I don't know how many. I mean, sometimes we have all 4 CO2 parameters measured, you know that CO2 system, actually you know because after 2 weeks you already know that we have CO2 system 4 parameters, and if you have 2 you can calculate other 2, and you did it, oh, it's not here anymore, on using this stuff. But now we more and more we have full measurements of, for all full 4 parameters. So I merge these parameters into CCHGO hydrographic file, and we work with Bobke again independently on QC on this particular data set from cruise, and then he has his methods, I have my methods, and then we compare results and find common, that we need to change flags, or find some outliers or inconsistency of data, or something like that. So that, and then I send final CO2 data to CCHGO, and in the end we have a CCHGO and CDAC. We have absolutely identical files. So you can go to CCHGO or CDAC to obtain these files, but only different. The CCHGO, it's a data assembly center, and CDAC is data assembly and data archival center. We archive data forever, I hope. And as to CO2 system, it's a place for at CDAC to look for data. So, but for underway measurements, many people do many different measurements with different tools, but in the end, we would like to have it's requirement elements. We developed this during IUCCP meeting in Japan. We developed this list of required parameters, elements, measured atmospheric information in a file, measured seawater information in a file, and sometimes derived parameters in atmosphere, CO2, for example, XCO2, and seawater, FCO2, PCO2, XCO2, and of course we have optional information, or optional like quality flags. So that's what we present. I mean, PIs should use in order to put together the file would be good file for underway PCO2 measurements. And that you can FTP if you don't want to use our system. You can just FTP to CDAC and put this data there. So this is very important information we have here, how to submit data to CDAC, because it saves time when people follow these forms, when people use format. It saves time for everybody, I think, and we have a lot of information too. And now I want to stop by CDAC publications, numeric data packages. We produce these numeric data packages for all data sets when we know that we have absolutely all information on hand. So we produce the books. In my case, it's CDAC in general. In ocean part of CDAC, I produced already so many numeric data packages, basically for all WOS cruises, and continue with Cliver sections, and of course measure databases like global database from Tara Takahashi. NDP. So our NDP, I showed you already NDP, that's what we produce, and we not just have online NDP, you can read online or download PDF file, but we produce hard copies of NDPs and distribute according to distribution list. Some people still want to have book on the table, like Dick Feely, just crazy about these books, and he keeps all of them on his table about these cruises, and especially when his name on it. Like here, yeah. So he likes it, and he's the first one who says, I always say, why do we need to just continue spend money on hard copies? He said, no, we have to do it because it's a way to go. So we make a very cool. If we produce hard copy, we make very cool covers for our NDPs, and it helps a lot. And again, NDP has all information you need to know about this cruise and measurements. Okay, and you can find here not just NDPs on CDAC publication, but also this very popular here, Handbook of Methods. It's so old methods was, by the way, this is the most most requested book. We were out basically for many years of printed copies, and people still want printed copy for this. DOE produced this handbook of methods for analysis in various parameters in carbon dioxide system. Andrew Dixon and Catherine Gayev were editors for that, and in '94 it was out. We had a lot, and we went out in a few years we didn't have any, so we had to print again and print again, and then we decided that it's already too old. And Andrew Dixon started campaign for new handbooks. So we have both online, because some people still make a reference to DOE '94, but we already have a new book which is available here, and you can download it as a whole PDF file, or you can use just different chapters or SOPs, which I don't really know what does it mean, SOP still. Okay, great. Sometimes I get confused with abbreviations. Okay, and again, if anybody of you want to have a handbook on the table, I can send it to you free of charge. Just send me email, because I already sent out. Just Chris requested, actually ICCP director requested for information how many books we already distributed. We distributed 390 books within just a few months when it came out, and it's available. I still have 500 in boxes in my office, so you can. If you need this book, if you're interested, you please send me an email. But also, you see, we have distribution centers like here, CDIAC. I'm distributing North and South America and Europe, and Canada has their own distribution center. China, Japan, Korea, and Russia. This all because this was published at PISIS. We call it PISIS guide, so it's available, and of course it's available online, so you can print it online. Okay, another publication very popular. It's CO2 system calculations. You already work with that, and you know what is it. We have all versions here. We have original version. We have Microsoft Excel version here, or MATLAB version, so you can go to CDIAC and get it. I'm sure you already got it. So that's what our publications are here at CDIAC. Anyway, so I think I will finish with 15 minutes. I'll finish with what did I do? With this one, and where did I stop? I wanted to show you a little bit some information on data quality, second level of data quality assurance. This is example of GLODAP. Bob Key wanted me to show it to you because it's very important. How did we do it? And so that's how GLODAP was created, using this all analysis. So we use analytical and calibration techniques for original data, and the results of shipboard analysis or certified reference materials. So this is all first level control, replicate samples.
Can you make that slide a little bigger?
Oh, I'm sorry. Yeah, I can. I'm sorry.
Yeah, thank you.
Yeah, you can read, right? Okay, and then we have consistency of deep carbon data at the locations where cruises cross over. We call it crossover analysis. So you just basically compare two cruises data. It could be from different years. And of course, you use measurements deeper than 2,000 meters for that. So they're not supposed to change so much. So we did that. And we use multiply linear regression analysis, size epic-null analysis, internal consistency and multiple carbon measurements. You know what is it, right? Everybody know what's internal consistency? It's when you have four measurements for carbon system. If you you measured 3 and you check when. So you use 2 to calculate third to check if it's consistent. So and opposite. So it's very good when we have more than 2 analysis on the cruise. Okay, and of course, final evaluation of offsets and determination of corrections to be applied. So that's what we did in the end of GLODAP. And here I have full explanation what we do. To, if you want, I mean, I don't know if you want to read. I don't want to read with my, accent. So you want to just briefly read what we did for calibration. I mean, I'm sure that you know everything about that, but just in case. I got this from GLODAP website. So it's on GLODAP website, all this information, how did we do it. And next one is analytical and calibration techniques continued for total alkalinity. And it's a description of methods, and it's a lot of publications on that. And we have for fugacity of CO2, F-CO2 analysis calibration. And pH, very short. And then results on shipboard analysis of certified reference materials. I'm sure that Andrew Dixon told you everything about that, so you don't really need to know. Replicate samples also, I'm sure that you had. We had a lot of replicates measured on board. And consistency on crossover analysis. Yeah, I said 2,000 meters basically. Here it says 2,500 meters below. Oh, it's by ocean, by the way. Yeah, I was right. It's in the Pacific Ocean. We use data from more than 2,000, deeper than 2,000 meters. No, what is it? 2,000 meters for Pacific, 2,500 for Indian Ocean, and 3,000 for Atlantic Ocean. Atlantic Ocean more mixed probably. And this is multiple linear regression analysis methods. So you can read about those methods in those publications. Isopycnal analysis. And internal consistency. That's what I told you. This is when you have more than 2 measurements of CO2 system, you can do. You calculate. We decided during GLODAP, we decided that the best combination of 2, it's total CO2 and alkalinity. So that's why we continue measure total CO2 alkalinity. But with ocean acidification program now, we have to measure pH. I mean, we can calculate pH, but it's better to have measurement. And so all cruises now equipped with pH measurement instrumentation. So we do measurements of pH. That's all. I think I'm done. We have 10 minutes for questions, if you have any.
If you have data sets which are very, very coastal, like we've got regular surveys each week going out over reef systems, small craft, is that something that would be appropriate to be updated and uploaded to?
You're talking about measurements of underway and surface, or?
No, not underway. We literally have, right now, NOAA is funding University of Puerto Rico folks to go out.
Okay, so it's bottle measurements.
Yeah.
Yeah, we divide. Normally on the transatlantic or transpacific routes, we don't have very close measurements to. I mean, you're talking about database we have right now here.
No, I mean, we're collecting that data.
Oh, you are collecting data.
It's appropriate to be submitted to CDAC, but they're only interested in large underway.
Okay, great.
Or these small regular survey efforts that are happening right up near the coast. Are those something that would be appropriate for the data?
Yeah, absolutely. We can, depending how close it's to coastal area, we can put it on a coastal website or on a global website. It's depending on those. I mean, if it's coastal area, you're talking about coastal area measurements, right?
Really close. We're literally running regular weekly surveys.
It's great. It would be. And what area is it? What ocean? Where is it?
It's in Lafayette, Puerto Rico.
Oh, okay. So it would be great for NACP actually. You would use this data because we're looking for very good coastal data for these projects as NACP and others. And yes.
Another large coastal data set that's growing now is called shore zone on the west coast.
Mm-hmm.
BC, Alaska, I think it goes down further to get to the States. And I suspect we're going to start adding CO2 measurements.
That's great.
So,
Yeah.
nice addition.
That's great. Yeah, we're looking for more and more data. The more we have, the better we are. And I'm sure that in the future we're going to do synthesis work for coastal data, as we did for global data. So it's necessary to do because coastal data actually it's very difficult to check because it varies so much and it's influence of rivers and sediments and everything. But we need to do it somehow. I don't know what methods we're going to use because it's almost impossible to compare coastal area data. Yes.
Do you interact with the NODC, for instance?
Yeah, we interact with NODC very much, and Hernan is here, my friend. Hernan worked for NODC, and recently we have a pact, or how do you call it, a document that for data exchange. And of course, we understand that NODC is a final destination for any data, and they're basically, they receive millions and millions of data. We are a special data center just for carbon dioxide. So, and Hernan learned how to, let's say it differently, that our Mercury system, which I told you about, as soon as I enter every data set we put online for public, if it's public, to Mercury. And Hernan would receive notification that overnight when Mercury updates that something new or something changed in Mercury, and particularly he will receive what something changed or what something new. So he would grab this data next day and put it on his world database. So yes, we interact with Hernan a lot.
You are great friends.
And we are great friends. Yes.
NOAA has a carbon tracker.
Yes.
Doing a great job collecting atmospheric CO2 data.
Right. Yes.
Compare CDX.
We don't have tracker yet, but why would we do it? Because they have already. So we just present normal data, and but I think I have links in my. We have at CDAC, we have related links. I think we have. I'm not sure, but I think we have a link to global tracker, carbon tracker there. It's a very good tool. Yeah. Yeah.
Alex, is there any plans to add ancillary data, like for example, sometimes it's useful to have meteorological data, like wind speed, weather, sea flow.
It's there. I mean, if we receive file with all meteorological information from VOS measurements, yes, we always have it online. We do have it, yes. I mean, most of the file most of the data comes to CDAC with wind speed, wind direction, and those stuff. Yeah. Yes.
I noticed a lot of the coastal data, you have the cruises listed, but the data are not available. Is that just waiting on publication and
Right.
release?
Yes.
How long does that usually take?
Well, we have rules. They changed now, but before, during WOS and beginning of Cliver, if it's transatlantic or, global cruise, it's 2 years for carbon measurements. CCSGO has data online right after cruise, but it's all preliminary, and they state that data preliminary and you can use it, but it's for your own risk. I personally don't like when CO2 raw data online because it changes so much. Even sometimes after we put it online, we still find some stuff, and we talk to PI, and then we change flags, for example. So we change data a lot. So I would prefer data to be online when it's public. So now we change it for 1 year. Clever change rules for 1 year for data status to become public, final and public. Yeah, we use it a lot.
Thank you, Max.
Thank you.